So here we are trying to understand that how an organic compound can be classified. So it can be, first of all, organic compound can be classified into two things. One is the cyclic compound and another one is acyclic compound. So let's talk about these acyclic and cyclic compounds one by one. First of all, we will try to understand that what is a acyclic compound. So let me tell you, acyclic compound is also known as the open chain compound. When we talk about a compound like alkane, alkene, alkyne, these all are an example of the acyclic compound. When we understand that compound like this, which is having open chain, are known as open chain compound or acyclic compound. Like this is also open chain compound. Okay, this is also an open chain compound. Like we can all form other type of compound as well. Okay, when we talk about the type of the acyclic compound, so they can also further classified into different types. One is the alkane, okay, another one is the alkene, okay, and another one is alkyne. And let me tell you, alkane is a saturated hydrocarbon. Saturated hydrocarbon, what we understand with the hydrocarbon is basically uh, organic compound which is formed by the carbon and hydrogen. Okay, so it is a saturated hydrocarbons. It means when we talk about the alkane, which is having the general formula CnH2n plus 2, it only have the single bond or the sigma bond. Only sigma bond is there, only single bond is there in the structure of the alkene. When we talk about the alkene, the general formula of the alkene is CnH2n. Okay, when we talk about the general formula of the alkyne, it is CnH2n minus 2. Okay, when we talk about the alkene and alkyne, these are also known as the unsaturated hydrocarbon. These are the unsaturated hydrocarbons. It means they will have the pi bond as well. It means they will not only have the single bond, they will have the double bond as well. Okay. And when we talk about the examples of this compound like alkane, the first simple example would be the methane. Then you can take the further examples like ethane. You can take the further example like C3H8. This is the propane. We can take the example like C4H10. This is the butane. C5H12, C6H14, C7H16. These are all the example of the alkane. What is the name of this compound? This is butane. What is the name of this compound? This is the pentane. What is the name of this compound? This is hexane. What is the name of this compound? This is heptane. Okay, so these all the compounds are alkane. When we talk about the alkene, so alkene start from the C2H4. It means this is ethene, C3H6. Okay, C4H8, C5H10. Okay, C6H12. Okay, and when we talk about C7H14, these all are an example of the alkene. Similarly, we can talk about the alkyne as well, like acetylene, or we can talk about ethyne, which is C2H2. We can talk about C3 H4. We can talk about C4 H6, mean double, then minus 2. Okay, when we talk about C5, what will be the number of hydrogen? Then you have to double the number of the carbon. Minus 2 means double, then minus 2 means C5H8. It is the pentyne. This is butane. This is propyne. This is ethine. Okay, when we talk about hexane, what will be the formula? You have to double the number of the carbons, means that would be 12. Minus 2, it means it will become C6H10. And you can observe one relation here as well when we talk about the next homologous compound of the alkyne, which will be having this difference of the CH2 group. So you can easily make the other formula of the next hydrocarbon, next alkyne, like it is having the C2H2 formula. For the next alkyne, the formula would become uh, CH2 you have to add, then it will become C3H4. When we talk about the next hydrocarbon, next alkyne, it will become C4, then number of hydrogens will be added. So here was 4 hydrogens. Now you have to add 2 hydrogen as well, so it will become C4H6. So this is how you can make the alkyne formula. Okay, so I think you got it what I'm trying to say with the term acyclic. Okay, so it will be having the open chain, and these compound are also known as the aliphatic compound. Why these compound are known as the aliphatic compound? The reason is really simple. When you try to decode this term, it means animal fat. So all these compound, when we talk about alkane, alkene, and alkyne, are obtained from the animal fat. That is why these compound, these acyclic compounds or open chain compound, are known as the aliphatic compound. Okay, when we talk about the alkane, this is also known as the paraffin, and when we talk about the olefin, which is the alkene. When we talk about the alkene, this is also known as the olefin. Okay, so these are the simple thing we know already about the acyclic and the open chain. We have taken some examples here as well. Okay, and we can make the structure as well. That is not a big task. Now let's talk about the cyclic compound. What are the cyclic compound, and what we understand with the term cyclic compound? So as you can see, as you can decode this term, cyclic compounds are those compounds in which first and the last carbon is connected through the bond. First and last carbon are connected through the bond. Okay, are known as the cyclic compound. Okay, for example, you can talk about like different types of the cyclic compound. Like this is a three-membered cyclic compound which is known as the cyclopropane. This is the four-membered cyclic compound. So when we talk about the carbon, 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 okay. And when we talk about the numbering, so it would be the first carbon, second carbon, and third carbon. You can see here that first carbon and the third carbon means the last carbon and the first carbon is connected. Means there will be formation of a ring, there will be formation of a cycle, and this is known as a cyclic compound. Similarly, when we talk about this compound, if it is the first carbon and it would become the fourth or the last carbon. Similarly, we can talk about this compound as well. This is